Hey y'all, welcome back, and we are getting ready to start our chapter 11, section 1. Chapter 11 is a lot about area, so hopefully it will be a chapter where you succeed, and it is a lot of review stuff. So just real quick, a thing we need to remember is if we are doing our area, we're always going to label our area as units squared or inches squared, whatever units you're working with. So this section we're going to deal with triangles and parallelograms, and the main ones we're going to focus on are rectangles and squares. So looking at our vocabulary, the bases of the parallelogram are either pair of parallel sides. So we would really have two sets of bases, whatever ones you can pick. And then the height of our parallelogram will be the shortest distance between the bases of the parallelogram. So if you look at, if I label my two bases and then I have my side, well, my side will really be my hypotenuse, and we know that the hypotenuse is the longest side, so that's why we create the height between the bases. And notice that I'm looking for that 90-degree angle. Where does my base and my height, where are they perpendicular? So we're really looking for that when we're plugging it into our equations. Starting with our postulates of the square. And if I go too fast, you can always pause these videos to keep writing or to review anything. So looking at your area of your square, the area of the square is the square of the lengths of one side of one of its sides. So we would say our area equals our side square. So we know our four sides are all congruent, so we can just square the side instead of saying side base times height. We would just say side squared because we're really just multiplying the same number. The area congruence postulate says if two polygons are congruent, then they have the same area. So congruent shapes equal congruent areas. Kind of like if I wanted to tile a floor, my tiles are going to have the same area, so I will know how many tiles I'll need to cover that floor. So moving on to postulate 26, the area addition postulate says if the area of a region is the sum of the area of its non-overlapping parts. So say I have a figure kind of like the one at the left. I don't necessarily have a specific equation for that, but I do have two specific area equations to find the area of a triangle and a square. So I can say the area of my triangle plus the area of my square will equal the area of my whole figure. So if we don't have a specific one, try to break up your figure in some way, shape, or form to manipulate it and create or get the area. Theorem 11.1 talks about our area of a rectangle. So the area of a rectangle is the product of its base and its height. Again, we are looking for the perpendicular segments. And our rectangle to the right, I would say this would be my base and my height. So I can take my base times my height to find my area of my rectangle. Let's keep going. Theorem 11.2 talks about my area of a polygon. So the area of a parallelogram, is the product of a base and its corresponding height. So again, like we were looking back up at the top, we want to find the base and its perpendicular segment, which would be my height. My side length isn't perpendicular, and it's the longest length from both bases, so I will not use that. So look for that perpendicular height that is created. And last, the area of a triangle. The area of a triangle is 1/2 the product of a base and its corresponding height. I like to think of a football field. If I want to find the area of my football field, of course I'm going to take my base times my height. But say I wanted to find half of my football field and I cut it diagonally, I'm going to take 1/2 of my area of my rectangle, which would really tell me my area of a triangle. So that's kind of how I remember the area of a triangle equals 1/2 my base times my height. That's really just half of my rectangle. So you might want to write this down. If it is an obtuse triangle, a lot of times your height will be on the outside of the triangle, so we can use that times our base that makes that perpendicular segment. If I have a acute, if I have an acute triangle, my height will most likely be on the inside, and then I can again use my base. And then if I have a right triangle, I will look for my 2 legs to multiply by 1/2 and get the area of my triangle. So again, if you need to slow this down or anything, or pause it to keep writing, you may. So let's keep on moving. Example 1 wants us to use 2 methods to see if when we solve this area of a parallelogram, do we get the same answer. So remember, the area of a parallelogram is base times height. So let's use, for the first method, AD is my base. So my height would then be CF. So everybody sees where my base creates a 90-degree angle with CF. So my base would be 9, my height would be 4. I'm just plugging those numbers into my equation, and I get the area to be 36 square units. Again, it is square units because of my area. Next, let's see if we get the same answer by using AB as my base. And my height to AB, the perpendicular distance to my base, is going to be BE. So the base will be 8 and my height will be 4.5. So I'll just plug those back into my equation, and again I get 36 square units. Alright, again, if you need to slow it down or stop, please feel free to do so. Again, I want you to ask yourself, what shape do I have? And then what formula do I need to use for each one? Another example we can talk about is find the value of x if my area, if I'm given my area of, let's say 14.3 inches, squared inches, and I have a rectangle. I'm not really sure what my base and my height is, but in this case it doesn't necessarily matter because I'm just multiplying them. So I would plug it into my equation as A equals base times height, because it is a parallelogram. And I know these are my base. I can call that my base, maybe that my height. And let's plug in, I know my area. So I would say 14.3 equals 1/2 x times 2.2. And again, I'm in inches. Go ahead and solve that. And you should get 13.1 inches. So again, it's just kind of can I plug it into my equation, and how do I solve that? You can go ahead and pause this, do checkpoint 1 and 2. And the answers you should get to be these answers below. So check yourself, and if you have any questions, you can always come and ask me at a later time. Let's keep on moving to example 2. So we want to solve for an unknown measure like we did up there with our rectangle. So the base of a triangle is 4 times its height. The area of the triangle, so my area of my triangle is 50 inches squared. We want to find the base and the height. So my area equation would be 1/2 base times height. So I'm going to keep writing those equations as to what figure. So let h represent the height of our triangle. Then the base is 4h. So this is my height, and this is my base, because it is created by that 90-degree angle. So I'll write my formula. So I would then just fill in the blank. My A is 50. 1/2 my base, which is 4h times h. I would then say 50 equals, distribute inside 2h squared. Divide by 2, I'll get 25 equals h squared, and then square root both sides to solve for h, and my h would be 5. So my height will be 5 inches. So my height is 5 inches, and the base is 4 times h, which is 4 times 5, which would be 20 inches. So what if I had a obtuse triangle and my height is 7? Well, where do I put my height? Oh, yeah, I need to make a perpendicular height with my base, which would be 12. I know my area of a triangle would be 1/2 base times height. I'm solving for my area, so I'm just going to plug it in. Area equals 1/2 my base, 12 times my height, 7, and I'm going to go ahead and solve. So again, if you have any questions on any of this, please feel free to ask at a later date. So let's keep on going through. Solve a multi-step equation, because we love our real-world examples in this class. So a robotic vacuum cleaner can clean 2 square meters of carpet in 8 minutes. About how long does it take for it to clean a carpet covering a room with the dimensions shown at the right? So we talked earlier about, man, I don't have all of the equations for all of the figures that I can maybe come up with. So sometimes I have to kind of cut the figure into being things that I know how to find the area for. So finding the area, step 1 of the carpet. So we can find the area of a rectangle and the area of a square, true statement. So if I kind of cut this over here, I know that this section would be 5 meters, which would leave me with my top section being 4 meters, because 4 plus 5 equals 9 meters, which they give us. Alright, so to find the area of my rectangle up top, I would say 4, which we came up with, times 9. So base times height, plus my area of my square, which we know is 5 times 5, or 5 squared. So I would get my area to be 61 meters squared. Okay, determine how long it will take the robotic vacuum to clean the carpet. So I'm going to take 61 meters squared, what I got up here in step 1, equals how many I have, I have 2 square meters in 8 minutes. So I know I need my meters to cancel, so I need to put my meters on the bottom, and I can clean in 8 minutes. So how long will it take? I'm going to do my top divided by my bottom, and I would get 244 minutes, which would be 4 hours. Go ahead and do your checkpoints 3 and 4. Your answers will be 7 feet in about 3.5 hours. If you have any other questions, feel free to ask at a later date. Have a great time doing your homework.